Assalamualaikum warahmatullahi wabarakatuh, everyone. A while ago, I wondered where those kind of from fabrics coming from. This question has been playing in my mind for a long time, and now I know the answer. Hi, I'm Saini, student AS1142A5, and today I would like to explore that with you. Stay with me. All of this happened because of this. Amines. What's amines things actually? Amines are the organic compounds that's derived from ammonia, where one or more hydrogen atoms are replaced by alkyl or allyl groups. Apart from that, those organic compounds have three classifications, which is primary amines, secondary amines, and tertiary amines. These classifications based on the number of hydrogen being replaced by hydrocarbon groups, for example, methylamine and adenine. In addition, amines are sp3 hybridized and its shapes are trigonal pyramidal geometry. What? Trigonal pyramidal geometry? Not tetrahedral. It's supposed to be tetrahedral when it's sp3 hybridized, right? In ammonia, the nitrogen atom has 3 bonding pairs and 1 lone pair of electrons. Because of those regions is a lone pair rather than a bonded atom, the observed molecule being trigonal pyramidal geometry rather than tetrahedral. Now you know why it become like that. Next, namings of amine. For naming, I divided it into 3. The common one, IUPAC one, and when amines plus functional groups 1. We go one by one. Firstly, common system. In this naming, we just need to name the alkyl group that attached to the nitrogen and add the surface amine as a word. For example, methylamine, methyl and amine. Got it? Secondly, IUPAC system. In this naming, it's just like an ordinary IUPAC naming, which is we need to find the longest change that attached to the nitrogen, drop the E word from the alkyl name, and add amine and that words. For example, N methyl ethane amine. The last one is amines plus functional groups. In this naming, we need to look at the functional groups. Because of what? When the higher priority functional groups like carboxylic acid, ketone, or alcohol present one chemicals, the amines is treated as a substituent using the preferred amino. For example, 4-amino 2-pentanol as for naming. Alright, now let's move on to the main topic for today. Question that playing in my mind. That is the uses of amine. For your information, amines show up in real life far more than people expected. They are deeply embedded in biology, medicine, and more. However, our highlight this time focus on industry uses. Let's get started. One of the biggest uses of amine is in making azo dyes. Have you heard about it? These are formed from aromatic amines through a reaction called diazotization, followed by coupling with another aromatic compound. For illustration, I brought to you aniline that produce aniline yellow, which give a bright yellow color. Another one is toluidine, which is produce dyes, pigments, and chemicals for coloring plastic and ink. Naphthylamine that gives a strong color like orange and red. Have you heard about the famous of metal orange in lab? It's also from amine. And then we got the malachite green, a dye derived from aromatic amine that produce a deep green color. Now I know where those colors come from. The favorite color actually come from amines. Okay, I'm done. In summary, amines play a crucial role in our life. Without it, our life is just a black and white stage. No colors, no goals, no life. Aha! It looks like we have reached at the end of the video. I hope all of you can get to know and understand more about amines after watching my video. Before I'm gone, don't forget to comment, like, and subscribe my channel for more incessant video coming soon. See you in the next video. Bye bye. Assalamualaikum.
I just had to let you know you're